Welcome to this session, which is titled The Passage of Air from Mouth to Muscle. This forms part of a series in relation to endurance physiology and cardiorespiratory physiology. And although the title is From Mouth to Muscle, this is very much a lecture which covers the notion of what we call oxygen uptake kinetics. The idea of what happens in terms of oxygen uptake at the onset of exercise. So if you have been through previous classes and watched previous recordings, the majority of what we focused on has been under incremental conditions, the traditional responses we see in a stress test. This is different. This is what happens when we perhaps isolate one of those stages in the test and we're doing now constant load exercise. And as you'll see, this is a fascinating area of exercise physiology. And it really opens up a Pandora's box for us in terms of being able to understand what is going on at a cellular level at the onset of exercise, and really how that has both clinical and performance-based ramifications. So with that in mind, the aims of the session are these. We're initially going to examine the mechanisms which contribute to that oxygen uptake at the beginning of exercise and then its utilisation. And we'll spend actually quite a large amount of time within this session doing that. The second part is then we're going to explore what is referred to as the phase-based responses for VO2. Now, if you have been through previous sessions and previous classes, some of this will have started to have been referred to, and we'll have started to cover topics such as, for example, the lactate turn point or the gas exchange threshold, maximal lactate steady state, for example, and respiratory compensation point. They've all been alluded to. Their relevancy and their currency comes into play here when we connect them to this idea of oxygen uptake kinetics. And then finally, we're going to understand the role of what is called the VO2 slow component, how this is connected to O2 kinetics, and how that is linked to both exercise-based performance but also clinical outcomes. Well, to begin our journey, we just need to refresh ourselves a little bit with this schematic, which is the original one, of course, came from Wasserman, and this is the updated one from Andy Jones. But what it does for us, if you remember, as we've covered in previous sessions, is it reflects for us this kind of integrated system in terms of taking oxygen up from the atmospheric air and delivering that to the mitochondrion for oxygen uptake within the tissue. And that process is fundamentally based upon the driver of the lungs moving into the pulmonary circulation, the action of the heart into peripheral circulation, and then into the tissue itself, where we fundamentally reflect what is going on in the mitochondria in terms of oxygen uptake, QO2 at the mitochondria, and QCO2, which is CO2 output at the mitochondria. So the CO2 is then sent back through the circulation peripherally into the pulmonary and is then expired. And we have this kind of balance that we're trying to achieve, particularly in exercise below the lactate turn point, LT2, where these are pretty much in balance. Sorry, apologies, these are pretty much in balance here, and would be reflected when we measure the data at the mouth in terms of a balance between O2 uptake and CO2 production. And just to remember that the derivatives of these kind of macro level measures, the meso level measures of these, are tidal volume and frequency for lung function, stroke volume and heart rate for cardiac function, and then QO2 and QCO2 for muscle-based function. So when we are exercising, it is very much that integrated response. And what we're going to explore today is how these respond as a unit at the onset of exercise. So we're not considering necessarily max exercise, we're not necessarily considering, for example, aerobic capacity-based work. This is the onset of exercise itself. And then this was a diagram that came from a fantastic paper by Dave Paul and Andy Jones, which is just on O2 kinetics. And it just drives it a little bit further, which it kind of says, well, actually, what is this related to? Well, the kind of the change in VO2, which is the delta VO2 over the delta time here, is actually taking place in the mitochondria. It's actually taking place in the cristae, which are the striations inside the mitochondria. And it just gives us another representation where we've got for here pulmonary circulation and peripheral circulation. We've just got it referred to slightly differently as the gas-blood barrier, here gas being in kind of the respiratory system into the blood, and then the blood myocyte barrier, that is coming from the peripheral circulation onto the myocyte for the oxygen to then be made available in the cell for the process of oxidative phosphorylation. Well,